In this video, I'm going to show you how I made this tiled bath, and in this tiled bath, you might notice that there are some tiles missing, and those have been deleted by the Self Pruning Node. And this is useful for any bath that has these concave areas where tiles would overlap. Now, when starting to work with the Self Pruning Node, it won't give you that much accurate results. I actually had to go to the C++ source code of the node to see what it does, and I found out that it can use the collision of the meshes to get that accurate. And this is also the exact method I used to make the tiled sidewalk for my road generator tool, which is available on Fab, which generates this kind of roads, which are all generated with the landscape splines, and it makes these intersections in a very precise way. And if you want to get it for your project, I will leave a link for it in the description below. But now I'm going to hide this graph and we're going to start working on a new graph. So let's make the new graph, create empty graph, and let's name it PCG bath, and let's add it to the level. And for the spline, we have a tag of PCG, so let's get that. And the first thing we do is get spline data, all word actors, and the tag is PCG. So now we have the spline in the PCG. Next is spline sampler, and we're going to make it unbounded, and we're going to choose distance. And for the distance increment, we will get back to it later. But now if we debug the spline sampler and make the points larger, we can see that we have made the points along the path. Now we're going to make the points across the path. And to do that, we're going to use create points grid. And let's debug these points. I'm going to make points in the origin of the world, and what we want is we want points on one axis, and that axis is the y-axis. So for the x things, if we make the x things less than the cell size, it will leave only one point in that direction. So we have one point on the x-axis. The z-axis is already lower than the cell size, so we also have one point on the c-axis. And for the y-axis, this value is the distance from the center to the right and to the left. So the distance from here to here is 1000. But what we want to do is we want to enter these values from the input so we can use parameters with them. And for the grid extincts, it's going to be influenced by the width of the path. So we can use make vector attribute, and we want to make a vector of 3 dimensions. And as we saw right here, the x and z need to be 1, so we need to make a float constant and keep it 1 and connect it to x and z. And for the y, we need to make a parameter. This is going to be half the width, so we can call it half width. And we can connect it to the grid extincts, and it is 0, we can make it 300. Now for the cell size, it's going to be influenced by the size of the tile. So now if we duplicate this, instead of entering 3 values, we can choose to enter vector 2 and a value. And for the z, we can make float constant, and we can keep it 100. And for the xy, we need to make a parameter, make it vector 2d, and name it tile dimension. And we can connect it right here. Let's make the default 50, 50. And now if we look right here, we have the vector. And now we can connect this to the cell size. Now we have the points across the path, and we want to copy them to the path. And to do that, we can use copy points. So now if we debug this, we can see that we've made the points along the path. And for the distance between the grids that we copied is going to be influenced by the distance increment. So if we make it larger, the points are going to be away from each other. And for this value, we need to depend on the x dimension of the tile. So here in the tile dimension, we need to take this value from it. And to do that, we can make float constant. And we need to copy an attribute. And we need to copy this. And now we can name this distance. And we can paste it here. So now if we connect this to the distance increment, we will see that the distance is influenced by the x value of the tile dimension. But now if we come back here and we select absolute and we make the points smaller, we can see that we have points overlap with each other, and that's why we need the self pruning node. Now in the self pruning node, if we debug it, we can see that it does a really bad job in clearing the overlapping points. And part of this is because it's using the instance, which is the size of the point, to choose which point to delete. And if we go back to the copy points, we can see that the points are actually in order. So it takes the first point from the grid and it copy it along the path, and then it takes the second point and copy it along the path. So the order of the points aren't random, and we can use that to choose which point to delete first. And to do that, instead of the instance, we can choose the order, which is the index. And the similarity factor is the tolerance. So if index is a 10, it will consider anything between 7.5 and 12.5 equal to the index of 10. Since we have a unique index to each point, we don't want any tolerance. We can keep this to 0. And now we can see it's a bit better. But for each point, it's also deleting all of the points around it, and that's because the points are touching. So if we get a multiply node and we get the points extinct, and we keep them at 1 for now, so we're not changing the size. Now if we reduce the size of the points, we can see that because the points aren't touching as much now, it can keep more points this way. However, doing it this way, you can see that it is not very accurate. So here we have a convex area, and this area right here, you can see that it has a lot of distance to add a tile, but it chose to delete them. And from here, if we get a static mesh spawner, and we add the tile that we want to use, which is called pavestone. And for this tile, if we open it, we can see that the approximate size is 19 times 40. So what we can do is make the tile dimension to the size of the tile that we used. We can add 1 to it to make a gap. So we can make it 21, 41. And now looking at the results, you can see that it's still deleting a lot of points where it doesn't have to. For example, here, you can see that it does have enough space to add tiles, but it chose to delete them. And if we make that even smaller, now it will keep those points, but it will leave points that overlap with each other. So we can fix this. If we go back to the self-pruning node, we can see that we can use the collision attribute, which will make this node very accurate. And to do that, we need to add an attribute, and we need to make a parameter and make it static mesh. And we can name it to mesh, and we can get it. We can also name this mesh. In here we can add the mesh. So now we have the attribute called mesh, and it has the mesh that we want to add. And now we can connect this to it, and we can say use collision attribute, and it already used the mesh attribute because it's the last one, but we can also enter it right here. And now we still have points overlap, and that's because we've made this very small. So what use collision attribute does, it will check all of the points that it is about to delete, and it will check if it actually needs to delete them using the collision of the mesh. But when we make this smaller, some of the points it won't even see that they are touching because the points are too small, so it won't even check their collision. But if we make it back to 1, now we can see that it is doing it very accurately. This is how I made the path with tiles without the tiles overlapping each other. Now if we go back to the original graph, let's open it. You can see it's a bit different. And here we are reading the dimension of the mesh directly in PCG without having to set the tile dimension. And we also added an attribute for the rotation of the tile, so it can be very flexible in having the ability to rotate the tiles. If we look at this, we can make the points rotate with this parameter, but we can also enter any value and it will keep the points not overlapping and with the right spacing between them. I'm not going to explain this in graph, it's a bit more complicated, but I wanted to show you what you can add to the graph to make it more flexible. But this is it for this video. If you found it helpful, please subscribe. If you have any questions, let me know in the comments. Thank you for watching.